Hello everyone. Today, taking a look at the quiz review. Gonna just do a few of the problems that were on the review yesterday. I know we did a couple in class, and just wanted to redo a couple, put it on this video before you go ahead and take your quiz for the DLD today. So let's start with number 8. This is the multiplication property of radicals. So you can go ahead and multiply what is underneath the radical. So you would end up with the square root of 8 times 10, 80. And then we need to simplify, so this is where we do that prime factorization, or we're looking for pairs. I kind of like to think of it as looking for pairs. So 16 and 5, and then 4 and 4. Okay, so we got a pair of 4s. Guys, you could break these down to 2 pairs of 2s. But anytime you find a pair, again, you can bring it outside of the radical. So 4 and 4. So 4 radical 5. The 5 staying in the radical. Okay. Let's do one of the divisions as well. I think it might be useful to do number 4. So here we've got 3 radical 10 divided by radical 8. All right. What I would do on this problem, I know radical 8, it's not a perfect square, so it's not going to simplify itself. So what if we thought of the 10 and 8, we put them under the same radical, which we can do. And so then we could reduce this fraction. This would become 3. Yeah, we're running out of room here a little bit. Right below, got 3, and then this would be square root 10 and 8. I could reduce those both by a factor of 2, and that would give me square root 5 over 8 divided by 2 would be 4. So, simplified here, I'd have 3 square roots of 5 on top. That square root of 5 won't simplify, so it stays in the radical. The square root of 4 on bottom would become a 2, so that would be our correct response there for number 4. All right. So I know adding and subtracting radical expressions, like looking here at number 5, if we're adding and subtracting, we can, again, only add if we have like radicals. So negative square root 2 plus 2 square roots 2, we can combine those. Those are like radicals. The radicals are the same. Okay, so negative 1 square root 2 plus 2 square root 2, that would be positive 1 square root 2. We can write that 1 out in front, but just like with an x, we don't have to write the 1 out in front. So 1 square root 2 plus 3 square root 5. There were no like radicals of radical 5, so nothing to combine that with. So this is just square root 2 plus 3 square root 5. Again, we don't have to write that 1 in front of the square root 2. 6 is pretty similar there. I'll do an example here where we don't have like radicals, okay? But we could create like radicals. So here we've got 7. We get negative 1 square root 5 minus 3 square root 45. So not like radicals, okay? However, if we simplified the square root of 45, so we'd have 9 times 5 here. And 9, of course, is a pair of 3. So we would have 3 square root 45 simplifies to negative 3. We got the pair of 3's coming out, so we're going to multiply by 3 with a 5. That square root of 45 turned into 3 radical 5. So then simplifying that multiplication, we got negative 9 radical 5. So we end up with negative 10 square root 5. This is negative 1 minus 9, so negative 10 square roots of 5. Again, here we had to create like radicals. So a little bit different than the previous problem. Number 8, very similar. You can create 12. You can reduce 12 and 27 to where they would end up being like radicals. All right, so here, again, checking to see if something is a right triangle, you use the Pythagorean theorem. But rather than saying they are equal, you're trying to check, are these things equal? So Again, a reminder, A and B, those are your legs, so those are the shorter sides. C is the hypotenuse, or the longest side. So when we're checking this, here my A and B would be 12 and 9. Doesn't matter the order I put those in, just that I know they're my A and B. My C, my longest side, is 13. So I'm checking to see if these are equal. So 12 squared, 144 plus 9 squared is 81. Is that equal to 13 squared is 169. So 144 plus 81, that's going to be 225. And that is not equal to 161. So no, this is not a right triangle. Right. And then these last couple problems, guys, these are just Pythagorean theorems. Both of these, notice, hey, x on both of these are legs. So you're finding a leg. Again, that hypotenuse is always the side that's opposite the right angle. So the hypotenuse here, C is 4. The hypotenuse of this other example is going to be 12. C is 12. So you're finding a leg. You're finding A or B on those last couple. All right. So just wanted to review a little bit before we took our quiz. Thanks for watching. Best of luck on that quiz.